coming home, I'm coming home. Tell the world I'm coming.
Hello everyone, welcome to my channel. Myself Bharat from Sri Venkateswara College of Engineering. Now we are going to discuss about conservation of laws and electrostatics in mathematics. Let us take the introduction to this. Introduction to conservation of laws and electrostatics in maths. Conservation laws in physics states that certain properties of an isolated physical system remain constant over time. In electrostatics, conservation laws play a crucial role in understanding the behavior of electric charges. Mathematically, conservation laws are expressed through various equations that describes a conservation of quantities such as charges, energy, and momentum. Conservation of charge. One of the fundamental conservation law in electrostatics is the conservation of charge. This law states that total electric charge in a closed surface remain constant over time. Mathematically, the conservation of charge is expressed through the continuity equation, where J is the current density and rho is the charge density. Gauss law in electrostatics. Gauss law is a key principle in electrostatics that relates the electric flux through a closed surface to the charge enclosed by the surface. Mathematically, Gauss law is given by the equation where E is the electric field, dA is an infinitesimal area element, and Q is the charge enclosed by the surface. Gauss law provided a powerful tool for calculating electric fields in symmetric charge contributions. Conservation of energy, electrostatics. Energy conservation is another crucial aspect of electrostatics, ensuring that energy is conserved in interactions involving electric charges. In electrostatic systems, the total electric potential energy of system is conserved as work is done against electric forces. Mathematically, the conservation of energy is expressed as a sum of kinetic potential energy remaining constant over time. Ampere's law in electrostatics. Ampere's law relates the magnetic field around a closed loop to the electric current passing through the loop. In static situation, Ampere's law simplifies to the given equation, where B is the magnetic field and I is the current passing through the loop. Ampere's law is a powerful tool for calculating magnetic fields in situations with symmetry. Conservation of momentum in electrostatics. Conservation of momentum plays a role in understanding the interactions between charges particles in electrostatic system. In the presence of electric fields, the momentum of charged particles can change due to the force acting on them. Mathematically, the conservation of momentum is expressed through equations that relate the forces experienced by charged particles to their acceleration. Faraday's law of electrostatics. Faraday's law of electromagnetic induction describes how a changing magnetic field induces an electromotive force in a closed loop. Mathematically, Faraday's law is given by the followed equation, where E is induced electric field, dI is infinitesimal path element, and phi is magnetic flux through the loop. Faraday's law is essential for understanding the generation of electric fields through changing magnetic fields. Applications of conservation of law in electrostatic problems. Conservation law is applied in various electrostatic problems to analyze behaviors of electric charges and fields. By applying conservation principles, mathematics and physics can predict the outcomes of interactions between charged particles. Conservation law provide a systematic framework for solving complex electrostatic problems and understanding the underlying physics. Mathematical formula of conservation law. The conservation law is electrostatics are mathematically formulated through differential equation that describes the conservation of charge, energy, and momentum and other quantities. These equations, such as continuity equations, Gauss law, Ampere's law, and Faraday's law, providing foundation for analyzing electrostatic systems. By solving these differential equations, researchers can gain insights into the behavior of electric charges and fields in various scenarios. Conclusion. Conservation of laws and electrostatic principles play a crucial role in understanding the behavior of electric charges and fields in physics and mathematics. By applying mathematical formulations of conservation laws, researchers can predict the analyze and outcomes of the electrostatic interactions. The study of conservation law in electrostatics not only enhance our understanding of fundamental physics principles but also provide a framework for solving practical problems in electromagnetism and engineering. Thank you.